How to determine what is the resistor to use to protect your LED. In order to determine that, we need to go to the basics. Take a look at Ohm's Law and it is all there. Ohm's Law describes the fundamental relationship in electrical circuits. As you may know, electrical circuits are basically voltage applied to a load and a current will flow. A load can be anything that will close the circuit for the current to flow, and it will flow as per Ohm's Law. What that means is considering an amount of voltage source in a circuit, current will flow in an indirect relationship to its resistance. That basically means more resistance will mean less current. We are going to go over some calculations. Assuming some given values, we can find out what is missing. First, let's take a look at some specifications for a LED. This is just an example taken from the internet, but it will be helpful to illustrate our thoughts. Pay attention to these values in the chart. Voltage forward and current forward. These are important for our calculations. For our calculations, we will use 2.5 volts forward and 20 milliamps of current as current forward. Voltage forward is the amount of voltage used to activate the LED. That is all it does. So that voltage needs to be subtracted from the source voltage as it is not actually used to flow current. The current forward is the maximum amount of current we should allow to flow in a LED without compromising its integrity. Let's put that to work. Assuming we will source 5 volts from our power supply, considering 2.5 volts of that voltage is only to activate the LED. Considering we will only let 20 milliamps of current to flow, what is the resistance we need to have? From the illustration above, we can see that the formula we are going to use is R equals V under I. Assuming the voltage is the remaining voltage after activate the LED, and the current is 20 milliamps, we will need to have a 125 ohms resistor to our circuit. Let's check that with simulation and in the workbench. I put together a circuit simulation to better illustrate what we just learned. As you can see, I have here a 125 ohms resistor. My LED is using exactly 20 milliamps of current when the circuit is supplied 5 volts. When I change values for the resistor, you can see that the current is indirectly affected. If I increase the resistance, the current will lower, and if I decrease, the current will increase. Let's take a look at a practical experiment.
Okay, I put together a small experiment here for us to check how the real world is gonna work. I have a power supply that is gonna source 5 volts to the circuit. I have my multimeter connected in series with the power supply, is in the positive side, so this actually has 5 volts on the top, and I'm gonna apply those 5 volts to all the LEDs that are on the table. The first LED has a 100 resistor, the second LED has a 217.08 resistor, and the third has a 330.2 resistor. So let's see how much current is being drawn from the 100 ohms resistor LED. So we have 20 milliamps. That's exactly in the edge of the LED. So that means that we are in the safe spot. The LED is not going to burn if you use this configuration. But you have to keep in mind that LED, although they are very similar regarding voltage forward, they might vary among different manufacturers. So put that in the 20 milliamps in the limit here. It might be okay to use with some LEDs, but it might not be so good to use with another ones. They might have a different voltage forward. So being the limit here is not actually very good, but this is what this is drawing for this specific LED. So let's go to the next one. we can see here that we are drawing 12 milliamps, and you can see that the LED is still in a bright spot, right? It's still brightening very well. So 12 milliamps is very easy to be driven by a GPIO in a microcontroller, which usually they source 20 milliamps of current, but we should not put to the top. We should have some gap in there in order for us to not stress our microcontroller. So this one would be a very good configuration to drive an LED using a microcontroller. Let's take a look at the next one with 330. And now we are drawing only 8 milliamps. And we still have a bright LED. So we can see that you can use a very big range. I would say that's everything between 200 ohms and 360 ohms would be safe to be used. We're not going to stress your microcontroller GPIO. You're not going to stress the LED. You're going to pull enough current to make it bright, and you're going to be in the safe side. So now let's do our final experiment. I want to show you what is going to happen if we don't use a resistor. So this is the resistor side, and the other side is passing by the resistor. I'm going to put my 5 volts in here, and let's see what's going to happen. We are drawing 600 milliamps. The LED is not even shining and is burning. At some point, it's just going to stop drawing current, and that's pretty much it. The LED is gone. So that's the reason we put LEDs before, because we don't want to draw more current than the LED is supposed to. And in order for you to figure out what is the resistance that you need to use, you need to find out what is going to be the voltage forward. Usually it's different from red, blue, and white LEDs. So you're going to have to figure that out and use the Ohm's Law to calculate how much resistance do you need. And that's pretty much it. I hope this was helpful. See you next time.